When I was in junior high school, a classmate told me that one side of the moon always faces the Earth. I was totally shocked, and today I still remember his proud face when I asked him why. Of course, he didn't know the reason, but still looked down on me since I didn't know this fact. Today we are going to study this problem. Let's start with a concept called inertial centrifugal force, or simply just centrifugal force. What is a centrifugal force? We know that force generally has an applying object and a receiving object. The force without an applying object does not exist. Then centrifugal force is such a virtual force. It is introduced for the sake of simplicity in scientific research. Let's take an example. It is a pretty common experience for everyone. Let's say we're in a moving car. Now the car is turning in this way. We will feel as if somebody's pushing us out and squeeze us into the other side of the car. Now we understand that the car is turning, but people are still moving straight due to their inertia. At this point, people will have a tendency to move outwards relative to the car. It seems like a force is applied to people, so we call this centrifugal force. So how big is centrifugal force? This force equals to m times omega squared times r. This m is the mass of the object, and this omega is angular velocity. Angular velocity refers to how fast an object rotates. The faster you turn, the greater your angular velocity is. And this r is the radius. We can see from this expression, the heavier you are, the faster you turn, the greater distance between you and the center point, the more centrifugal force you will receive. After understanding this, we can explain the tide problem. Let's talk about how the tide is formed first. This is the sun. When the Earth is orbiting the sun, the Earth receives gravitation from the sun. But why it doesn't run up to the sun? It is because the Earth is receiving another force, the centrifugal force, F. According to Newton's law of universal gravitation, the gravitational force should be equal to G times capital M times lowercase m divided by r squared. In other words, this force is increasing when two objects getting closer. At this Earth's gravity center point O, the gravitational force is exactly equal to the centrifugal force. Then the Earth will make a circular motion. But what would happen at point A? Because point A is closer to the sun. R is smaller. So the gravitational force is greater at A. Then let's look at the centrifugal force. The m and omega have not changed at all, but the r is smaller, so the centrifugal force is smaller. Then the gravitational force is greater than the centrifugal force. The net force at point A is pointing to the left. This force is called tidal force. Let's look at point B, far from the sun. The gravitational force decreases as the distance increases. The centrifugal force is proportional to the radius. The larger the radius, the greater the centrifugal force. So the gravitational force is less than the centrifugal force. Therefore, the net force at point B is outwards. This is also called the tidal force. In summary, although gravity and centrifugal force are equal at the center of Earth, they are different at point A and point B. The net force at A and B are pointing to the left and right, respectively. So what happens if the Earth's surface is covered with water? This water will cause bumps at point A and B under the action of tidal force. This is the solar tide. Point A and B are high tides and the other two sides are low tides. This is the principle of tides. Not only the sun has its tidal power, the moon has it too. And the tidal force of the moon is greater than that of the sun since the moon is much closer to the Earth. So the tide on Earth that people observe is actually a combination of the solar tide and the lunar tide. Someone may ask, when is the high tide and low tide of this combination then? Let's talk about the high tide first. This is the sun, and this is the Earth. And there is a moon, If the moon is now in the middle of the line between sun and earth, the sun illuminated the left side of the moon. But to the right of the moon, people on earth can barely see any light from it. So the moon is almost invisible, and this is called new moon. This day is the first day of a lunar month. Solar tide and lunar tide are accumulated at this time, and the high tide are found on both sides. This high tide is also called spring tide. Actually, it's not only the new moon causes high tide, the full moon has the same effects. The full moon goes to the back of the earth. It will also rise tides towards solar tide. That is, spring tide appears on new moon and full moon. There's another kind of situation. When the moon is at first quarter or third quarter, the sun and moon are separated by 90 degrees when viewed from the earth. At this time, the solar tide requires the high tide to be on the left and right sides, and the lunar tide is asking the high tide to be on the top and bottom. In contrary to the solar tide, left and right sides are low tide. At this time, solar tidal force partially cancels the moon's tidal force. This is called the neap tide. Neap is an Anglo-Saxon word meaning without a power. Last question. Why the moon always faces Earth with the same side? This phenomenon is also called tidal locking. You see, this is the Earth, here's the moon. Since forces act on pairs, lunar surface should have this tidal force too. But the moon has no oceans. It is mostly made of rock. In this way, after a long time, the moon is not a sphere, but more like an ellipsoid. The long axis of the ellipsoid must always face the Earth. Why? Could it spin a little bit? Like the long axis is not facing the Earth at this position. This will not work. And why not? Because at point A, the Earth gives its gravitational force F1. At point B, the Earth also gives its gravitational force F2. And point A is closer to the Earth than point B. F1 is greater than F2. Under this combined action of these forces, this moon will be rotated back. After a long time, the moon is always facing the Earth with the same side. This is so-called tidal locking. You may follow up by asking, since the moon can be locked, why can't the Earth be locked too? Actually, given enough time, the Earth can also be locked by the moon. How long does this take? This will not happen until the sun becomes a red giant star and devours the Earth. Are there any two planets that are locked to each other now? Yes. They are Pluto and its largest moon, Charon. They have been running for a long time and tidal locked to each other, facing two loved ones until the end of the world. This is their sweet love story. Thank you for watching. If you like this video, please remember to subscribe, click the thumb, or leave a comment. We will see you next time.